All right, it seems maybe we're up and running now. All right, we are getting into theoretical and experimental probability. So a couple things to talk about today is probability. It's how likely an event is to occur. It goes from 0 to 1. 0 means never going to happen, and 1 means it's definitely going to happen. Okay, so theoretical, this is the possible ways it could happen. It's just like rolling a dice that you see here, and then um, not actually rolling the dice over and over and over again to find out. Maybe the dice is rigged a little bit somehow. Maybe it's a little weighted one way or the other. This is just saying, if I did this whole bunch of times, what's the probability that that would happen? So the way we show that is probability of rolling a 3. Well, how many 3s do we have on the die? It's 1. How many sides are there? There's 6. So it becomes 1/6. You can get your decimal. That's going to be your best way to compare um, probabilities between different things, but not required at this point. Okay, what's probability you roll an even? So I might say probability of an even. Well, how many of those out of the 6, how many are even? 2, 4, 6. Okay, so that's 3 of them. Okay, so sometimes you'll see me jot some things down. So that's 2, 4, 6, just to keep track of them as we work through things. So this is half the time. Half the time they're going to be even, so that's pretty good. It's probably you will not roll a number greater than 2. Okay, so this is where we really start to do. So we have 1, 2, 3, 4, 5, 6. Okay, so we will not roll something greater than 2. Well, that's 1 and 2, so that's 2 out of 6. So it's 1/3 of the time. So we're going to be careful with some of these negatives, the not roll. And then also this is where you're going to see me lay some things out about just showing it. And then I think it's a really good habit that we don't get mixed up of what you're trying to do. The next one, we're going to talk about the months of the year. So if you can get that mindset in there. So we get 12 slips of paper. Each one represents month. So probability that it starts with a J. Well, first of all, we agree there are 12 months in the year. But you will find 3 of them to start with a J. So that's a quarter of all of them. Ends with a Y. How many months end with a Y? You're right, it's 4. So that's 1/3 of the time. How many months have exactly 30 days? All right, everybody count their knuckles. Good, 4. So it's 1/3 of the time. And how many months have less than 28 days? Less than 28 days. That would be none of them. Good. So probability can be 0. And the greatest thing, the best thing that can happen is that we end up with 12 out of 12, which is 1. But I don't have that as a question in front of us today. But just remember, probability is always between 0 and 1. All right, so that gives us a chance to roll on up to the next page. If OneNote will agree with me there. There we go. It's tired. All right. All right, so how many marbles we have? 5, 10, or 15, 22. All right, so that's one thing I like to get. Before we get into anything else, just figure out what are we dealing with? Probability of getting a red. So probability of getting a red. There are 10 red ones. All right, so that's 5/11ths. Okay, so just saying 10 out of 22 would work, but 5/11ths is reducing, and we like to reduce those. Probability of pulling a green. So I might say probability of a green. Remember, there are still 22. This is not in conjunction with the previous pull. This is, that's going to be in our next lesson. Okay, so just pulling a green, that's 5. 5 out of 22, that doesn't reduce. We'll be done with that one. Probability of pulling a marble that is not blue. Ooh, okay. So we're going to work on reverse here. So it is out of 22, but we went not the blue ones. Well, if I went not the blue ones, that means I'm going to take out the 7. So that means 15 of them are possible. That's out of a 22, so that doesn't reduce either. Okay, so probability of not green. So sometimes you might see this as like an NG to say not green. Once you have the context of the question, I could have said NB up above there. So here, that means we're going to take out the green ones. And I went too far. I don't remember how many there were. No green, so that makes it 17 out of 22, and that does not reduce. Okay, so a couple of different ways to lay those out. All right, our next set of problems here has to do with this cute little circle probability. So we're not actually going to throw any darts this time. We're just saying, let's just say that we were the distance between the rings. So we have to understand a couple things going on here. So that means they're saying this is +2, and this is +2, but that means this one would have to be +1 because we're talking about a diameter at first and then increasing the radius. So why do we need to know that? Because we have to figure out what in the world's going on here. So what's the probability of hitting the bullseye if the distance between the two rings is 2 inches? Okay, so what's the radius of just the bullseye is 1. So area of the bullseye is pi r squared. So that's pi times 1 squared. So it's just pi. All right, what about the whole thing? What's the radius of the circle? So I might just do that one as the entire circle. So it's pi times r squared, which is pi times 1, 2, 3, 4, 5. So 5 squared, so it's 25 pi. So probability of actually hitting it is 1 pi over top of not hitting it is 25 pi, so it's 1/25. Well, that's not a very good chance. Well, that's why it's so much fun, right? All right, so again, we had to find the area of the bullseye, and this one was a little bit tricky the way we had to work in and the bullseye. So the entire distance, in other words, the diameter was 2, so that makes the radius 1. All the other we're going to increase by 2 inches. So we had to have a little bit of setup going on in here. Okay, this is what we're building up to. I don't think that you're going to find too many of those to work on all by yourself just yet. All right, so that was all theoretical. So here's experimental, and you only have one good one here. Mr. Jansen made this question a couple of years ago. It cracks me up every time because, you know, every comedian has like a rubber chicken. I don't know why. It's just part of the gig, I think. Well, it used to be when I was young. That was a long time ago. So this is something that you do in science class. It's something you observe. Okay. This isn't I rolled a dice and it could be a 2 occurs 1 out of 6 times. This is I rolled the dice 4 million times and 2 came up 14 times. All right. There's something wrong with that dice if those are the numbers. All right. But this is how it works. So spot checker, rubber chicken factory, inspects 500 chickens per day. 10 are found to be defective. What's the probability the rubber chicken is defective? Well, how many were defective? 10. How many got checked? 500. All right, so that's 1 out of 50. Here, we may want to use some decimals. Okay, so that's 0.02. That's pretty good, right? That's pretty good. So the next thing is now we're going to take, and they have made 100,000 of these chickens. And how many would you think that they need to throw out because they've been defective? So 100,000. So instead of setting up a whole entire proportion, now what we've done by using our experiment is we said, okay, that means I would expect to have a waste of 0.02. Okay, so 2% of those, that's 2,000 of those chickens are going to be defective, so they should be thrown out. Okay, so that's how experimental works. And we'll use more of that as we get compound probability in the future.